So we're adding multiple forces together. There's charge 1, charge 2, charge 3. If I want to find the force on 1, this equation only has room for 2 charges. But I have 3 charges. So what's going to happen is I'm going to find the force between 1 and 2. We'll call this F1, 2. And then I'm also going to find the force between 1 and 3. And we'll call that F1, 3. To get the final answer, I'm going to add those 2 forces together. So the force on Q1 is going to be equal to the force between 1 and 2 added to the force between 1 and 3. Now, you might be saying to yourself, well, isn't there a force between 2 and 3? Yes, but it has no effect on 1. Okay? Here's an example. You and 2 of your friends are sitting in a circle, and on the count of 3, you all slap each other in the face. Okay? At 3, just everybody smacks the other person in the face. Okay? If you want to find the force on you between Georgina and George, you would add the force between George and your face and Georgina in your face. You would not add the force between George and Georgina. You don't care how hard they hit each other. It only matters how hard did they hit your face. If you're looking at the force on Q1, it only matters the force on Q1. It does not matter the force between 2 and 3. That doesn't matter. All right, so let's set this up. Let's solve it. I'm going to give you some warning. You're either going to love these problems or you're going to hate them. There is absolutely no in between. You're either going to love them because they're very methodical and they're nice and you just do them and they work out and they're very systematic in how you do them. Or you're going to hate them because there's a lot going on. The good news is the homework is one problem, and one problem, that's it. Okay? All right. First thing you should do, 3 charges, Q1, Q2, Q3, lie on the x-axis at 0, 3, and 5 centimeters respectively. That respectively just means 0 goes with 1, 3 goes with 2, 5 goes with 3. That's what it means. Okay? Calculate the magnitude and the direction of the electric force on each of the 3 charges. If Q1 is this, Q2 is this, Q3 is that. The first thing you need to do is draw a diagram. So here's my 3 charges. At x equals 0, I have Q1. And Q1 has a value of positive 6 times 10 to the negative 6th. Here is my second one. Okay, this is at x equals 3 centimeters. Okay, we are going to need them to be in meters, unfortunately. I'm usually going to give them to you. In fact, in the problem, I think I gave them to you. Yeah, I gave them to you in meters. So I'll just go ahead and put them in meters for you here. This would be 0.03 meters. And this is going to be, so this is x1, x2, and this is Q2. Q2 has a value of positive 1.5 times 10 to the negative 6th. And here is, lastly, x3, which is at 0.05. And that has a value, Q3, negative 2 times 10 to the negative 6th. Okay, the first thing we need to do is we need to find the force on Q1. Okay? Oh, good, I got enough clothes. Time to bring in the cavalry. All right, let's start off by finding the force on Q1. The force on Q1 is going to equal the force between 1 and 2, which I'm going to call F1, 2, plus the force between 1 and 3, which I'm going to call F13. So, to get FQ1, we have to add the force between 1 and 2 to the force between 1 and 3. Notice that I did not include the force between 2 and 3 because that has no bearing on 1. Questions so far? Good. Okay. I need to find these. I don't know what these values are, so I need to find them. I do that by doing my equation. F12 is equal to K Q1 Q2 over D squared. So K is 9 times 10 to the 9th. That's given in all the problems. Q1 is my first charge, which happens to be Q1. 6 times 10 to the negative 6th. And I'm going to put out, by the way, I'm going to put out colored pencils if you want to color coordinate stuff. Actually, they're in the back already. If you want colored pencils, they're in the back between the two sinks. And Q2 is going to be Q2, which is 1.5. Again, notice I'm not putting any signs in. We'll get to that later. Oh gosh, ran out of room. Negative 6, there it is. Yes?
Before this entire problem, see where you have the pink FQ1 plus, yeah. So
yep.
Is that, like, so you have the green over the pink, but that doesn't make sense. Like, why?
It's F, so this is the total force on Q1, okay. Is the force between 1 and 2, which is this here, plus the force between 1 and 3, which is this here. This is not on, I didn't draw this. This would be like what happens to this here.
Okay.
Okay. And then I'm going to divide this by the distance between them squared. The distance between 1 and 2 is 0.03. To go from 1 to 2 is 0.03. So 0.03 squared. Okay, I'm going to just plug it all into my calculator. I'm not too worried about the math just yet. I want to get through the concept setup first. So follow along with me to make sure you can plug it in. But I'm going to go ahead and just plug the numbers in to save a little bit of time here. So 9 to the 9th times 6 to the negative 6 times 1.5 to the negative 6. Divided by 0.03 squared. Gives me 90 for the force. Hello? Yeah. Yeah. Yep. Yep. Michael, grab your stuff and head on down to the ALC guidance office. It's a good place. That's a good place to go. It's not the clinic. Don't want to go to the clinic. Okay? So that's my first one. You might just double check to make sure you can get the same math as me, but right now I'm just focused on the overall problem solving aspect. Now, I found F12. So, here's my force on Q1. It's going to be equal to the force of 1, 2. So I'm going to plug that number in. 90. Okay. Now I need to find the force between 1 and 3. So, same equation. K, 9 times 10 to the 9th. Not you, that one. Pappas, not Griffin.
Okay.
Okay, now I'm plugging in Q1 and Q2 for this one. Q1 for this one is still Q1. Okay, 6 times 10 to the negative 6. But Q2 this time is actually Q3. This is the force between 1 and 3. So Q2 is Q3, which is negative 2.0, but don't plug in the negative. to the negative 6. Plug in the negatives for the powers. Don't plug in the negatives for the charge. And then that's divided by the distance between them. From 1 to 3 is 0.05 squared. And when I plug this in, I get 43.2 newtons. Plug that in here, 43.2. Okay, we're almost done, kind of. Now, we got to add these up. But here's the thing. Remember I said ignore the sign, ignore the sign, ignore the sign, ignore the sign. You can't actually do that. So, we need to decide the direction based off of these charges. So how do I figure that out? Here's how I figured it out. I ask myself, what direction will 1 move because of 2? Well, 2 is positive, 1 is positive. I know that opposites attract, like charges repel. These are both positive, which means this will move to the left to get away from Q2. So Q1 will go to the left to get away from Q2. That means the force between 1 and 2 must be negative. Nope. Because I think you're thinking about Q2. Q1 is to the left of Q2. So if they repel, Q1 has to go to the left to get away from it. That doesn't matter. Size doesn't matter. Nope. Size of the charge doesn't matter. Nope. One thing that might be helpful, assume that the other charges can't move and only the charge you're looking at can. Okay? So Q2 or Q1 is going to be negative because of Q2. Their like charges are going to repel. So this one will get repelled away, which is left. So now we look at Q1 and Q3. Q1 is positive, Q3 is negative. That means Q1 will go towards Q3. It'll be attracted, so the force between 1 and 3 will go to the right, which means this is a positive 43.2. So now we're ready to finish the problem. We add them up. Negative 90 plus a positive 43.2 will give me a negative 46.8. Okay? Oh, wait, it's not done yet. I just found the force between 1 and 2 and 1 and 3. I found FQ1. But the problem said calculate all 3 of them. Which means now you got to do FQ2. Yep. See, it's going to be so much fun. Now, I got good news. Each time you do it, it gets easier. Not like, oh, I'm better at it. It literally gets easier. FQ1 is going to be, or FQ2 is the force between 1 and 2 and 2 and 3. Hey, guess what? I already found the force between 1 and 2. So don't find it again. It's 90. And guess what? Newton's third law, every action has an equal and opposite reaction. If the force on Q1 from 2 would push 1 left, then the force on 2 from 1 would push 2 right. This is a positive 90. Now I've got to add in 3. The force between 2 and 3. And I would have to set up the equation for that now.